Hello everyone. In this question, it is said that if yx be the solution of the differential equation dy dx equal to 1 plus y sec x, where x ranges from minus pi by 2 to pi by 2, and y of 0 is equal to 0, then we have to find the value of y of pi upon 6. Okay, so let us start with the solution. The differential equation given is dy dx equal to 1 plus y sec x. Okay, and x is in the open interval pi upon minus pi upon 2 to pi upon 2. Okay, so rewriting the differential equation to the standard linear form, if I take this y sec x to the other side, it will become dy dx plus minus sec x times y is equal to 1, right? Which is of the standard linear differential equation form, dy dx plus py equal to q. Okay, where p and q are your functions of x or constants. Okay, so in this case, p is your minus sec x and q is 1. Okay, so this implies the integrating factor is given by e to the power integration of p dx. Okay, so we get the integrating factor e raised to the power integration of minus sec x dx. So on integrating this, the minus goes out here, and integration of sec x dx is nothing but ln sec x plus 10x. So now this is this minus 1 is in front of the logarithm, so I can take it to the power. Okay, so this becomes ln sec x plus 10x inside the modulus whole raised to the power minus 1. Okay, so we know this formula e raised to the power ln x is nothing but e raised to the power log x base e. This is what ln is, right? Natural logarithm, and this is equal to x, right? So in this case, our x is mod of sec x plus 10x whole raised to the power minus 1. So this becomes nothing but your 1 upon sec x plus 10x. Okay, so this is the integrating factor. So the solution is give of the form y times the integrating factor is equal to q times the integrating factor, the integration of q times the integrating factor plus a constant of integration. Okay, so now we get y times 1 upon integrating factor is sec x 1 upon sec x plus 10x, right? And q is nothing but q is 1. Okay, so this implies this now becomes 1 times this integrating factor is 1 upon sec x plus 10x dx plus c. Okay, so I keep the left hand side as it is, 1 upon y times 1 upon sec x plus 10x, and there is no direct formula for this, right? So let me try to rationalize this term. So I multiply this sec x 1 upon sec x plus 10x. I try to rationalize this by multiplying the numerator and denominator with sec x minus 10x. So this becomes sec x minus 10x, and this becomes sec x minus 10x times sec x plus 10x dx plus c. So again, I don't change anything in the LHS for the time being. And now this becomes x square x minus 10 square x, right, in the denominator. So in the numerator, I have sec x minus 10x, and this becomes x square x minus 10 square x dx plus c. So this further gives y times 1 upon sec x minus 10x is equal to integration of, this becomes 1, right? Sec square x minus 10 square x is 1. So the denominator vanishes, it goes to 1. So I have integration of sec x minus 10x minus 10x dx plus c. So this implies the right hand side now becomes integration of sec x dx is nothing but ln mod of sec x plus 10x. And this integration of 10x minus 10x dx is nothing but ln mod of sec x. And the plus c remains. Okay. So now this becomes ln, this is ln a minus ln b. So I can rewrite it as ln of a upon b, right? So this becomes sec x plus 10x in the numerator upon sec x. So this now becomes finally sec x upon sec x is 1, right? Plus this 10x upon sec x. Let me try to find it in the graph. Okay, I have 10x upon sec x, right? So 10x upon sec x. Now 10 is nothing but sin x upon cosine x, right? And sec x is nothing but 1 upon cosine x. So this ratio now becomes just sin x, right? So 10x upon sec x becomes sin x. So this now becomes 1 plus sin x plus c. Okay, so now I can use the initial condition. The initial condition given was y0 equal to 0. Okay, so I'll use that here to find the value of this constant c. Okay, y0 equal to 0. This implies that if I use 0 here, this LHS will become 0, right? Y times 0. This becomes 0. And here the value of x will become 0. So this sin 0 will become 0. So this becomes ln of 1 plus 0 plus c. Okay, so this implies this 0 will become ln 1 plus c, right? And ln 1 is again 0. So this becomes c. So the value of c is now 0. Okay, so we see that the constant is now 0. So this implies, from this equation, this implies that y times 1 upon sec x minus 10x is equal to ln mod of 1 plus sin x. So if I write this as a function of x, y as a function of x, I will get it y of x is nothing but sec x minus 10x times ln 1 plus sin x, right? After cross multiplying this term. So we have to find the value of y of pi upon 6. So this will become sec pi upon 6 minus 10 pi upon 6 times ln of 1 plus sine pi upon 6. Okay, so sec pi upon 6 is reciprocal of cos pi upon 6. Cos pi upon 6 is root 3 by 2. So this is 2 upon root 3. And this will become 2 upon root 3. Oh, sorry. This will be a plus. See, it was plus here. I just rewrote it as minus. So it was my fault. So this will remain as plus. So this is plus again here. Sorry, my mistake. And this will be plus again. Okay, so this now becomes 2 upon root 3 plus 1 upon root 3. Okay, and this now becomes 1 plus sine pi upon 6 is half, right? So this becomes 1 plus half. So I remove the mod here because this 1 plus half is 3 upon 2, right? So this is a positive number already. So I don't need the modulus. It is already a positive number. So I am removing the modulus here. So this becomes 2 plus 1 is 3. 3 upon root 3 times ln of this will become 1 plus half is 3 by 2. So again 3 upon root 3 will become root 3, right? So this becomes root 3 times ln 3 upon 2. So this is the final answer. Okay, this is the value for y of pi of 6. Okay, so this was relatively simple. I made a mistake. I rewrote this sec x plus 10x as minus. So I had a mistake here, slight mistake there. And I think the rest is all right. Yeah, the rest is all right. Okay, so this is the final answer. Okay, thank you.